let us get started on the very first topic, which is search. We will only talk about the philosophy of search today. So, what is our goal, right? The topic is search, but why are we interested in search? Let us first think about that particular question. So, our goal is to solve every problem in the world. Okay? You suddenly get a problem in your mind, and is there an AI algorithm that you can give this problem to, and the AI algorithm at least can in principle attempt it. That is our goal. Because if you have a brain, there is a fundamental some algorithm running there. That algorithm should be able to deal with all kinds of problems, right. In fact, I remembered there was a very beautiful quote, not a quote, but a thought that somebody shared with me. He said that if a person is good at one thing and they are good at another thing, there is a good chance that they are just generally smart people and they will be good at many, many things. So, I have seen many people who are really good at one thing, and they have become good at one thing by sheer practice, rote and teaching, by teaching as in learning from a teacher. And that is okay, I am not taking any credit away from them, they have worked hard at what they do. But then you will find some people who are just naturally intelligent, right. You give them a new kind of problem and they will be able to observe it, analyze it and quickly give you some insights in it, which many other people will not be able to do. And I would say that we are interested in that core that allows someone to be intelligent or good at many different fields, things that it may not have seen and learned for a very long periods of time. And that is something what AI people, AI researchers are also motivated by. Is there one AI algorithm that can solve all problems? And that is where this whole notion of search started, right. But before we get to search, which is the algorithm, they asked a very important question. Well, if there is one algorithm that can solve every problem, that means every problem in the world can be converted, and this is one algorithm, so it will only take one input, obviously. If this AI algorithm was taking many different inputs, then it will not be one algorithm. One of my senior mentors used to say that don't think about the algorithm, think about the input and the output. That will tell you a lot about what is going on in the world. It's actually a beautiful thought. You will not appreciate it today, but just note it down. When you have a discussion with someone and you are not able to figure out what is the problem they are trying to solve, just ask them, okay, we want to build a computational box, tell me what will be the input and what will be the output. And notice that if there is not enough clarity in the air, the other person will be confused in answering this question. Don't think about how, think about what goes in and what comes out first. I want to save the world computationally from hunger, okay, great. We want to build a computational system, what will go in and what will come out. Now, you can say all the data about food, hunger will go in, all the extra surplus of restaurants will go in, and output would be how to distribute food from one restaurant to nearby poor person. I am okay with that. Now, there is some clarity here, but before that there is no clarity. So, think about the input and the output. So, the folks said, or I guess they did not say it that way, but when we post facto rationalize it, understand it and construct it, reconstruct it, they said that we want to build one algorithm. This algorithm is expected to solve all the problems in the world, but because there is one algorithm, it can only have one input. That means technically we should have a way to convert all the problems into the world of the world in one input representation. Does it make sense? There should be one uniform way to convert any problem, computational problem, into that representation. So, the question is, what is that representation? Is there a one single representation that can, that I can convert any computational problem into, and then I have this uniform representation, so I can give it to the AI system and that AI system can solve it for me. If so, what is that representation? And this led to a lot of thought, and they came up with first a fundamental concept of a state. They said that in my general representation of the problem, I will have a state. What is a state? And you will get more and more appreciation of what is a state as you go forward in the field of AI. But for now, let us just say that all information about the environment could technically go into the state. In fact, all information about the environment and all information about me, how I think about anything, can go into the state. But then this may become prohibitively huge. For example, you want to make a plan for going from this point to that point. In this context, it does not matter what class is going on in the neighboring room, but technically what class is going on in the neighboring room is also part of the state. But then you will say, oh, whether it has rained in New York today is also part of the state, and who is the Prime Minister of India is still part of the state, but that is not relevant if I want to move from this point to this point. So therefore, the world may have many things, but when we create a computational problem, we abstract it out and we say we will put in the state what is important for us to make the next decision for the task at hand. So if our task is navigation, we will put our location, current xy coordinates, maybe we will put the neighboring obstacles, maybe we will put all the obstacles in this room, we will put where you are sitting, where you are sitting, which seat you are sitting, that way you will know how far the distance to humans is, etc., etc. All of that makes sense, but whether it rained in New York or not, we will not worry about, because we do not expect the robot to be able to fly to New York, and even then that should become part of the state for a different problem there. Right? So that is the first issue. We will define a set of states and we will put any information relevant to the decision mechanism in that state. Okay? Then the next question is, how would we represent this state? Okay? And this slide we will keep coming back to, and we will understand it more and more and more over time, but there are many views. One view is that every unique state is a number. So Vishwajit is sitting on chair number 1 and Harsh is sitting on chair number 15 and so on and so forth. That forms a state. Now I will call it state number 237. And if Vishwajit stops sitting at chair number 1 and starts sitting in chair number 35, we will start calling it state number 3997. And each different state will be a different number for me. And I will not go inside it as to where Vishwajit was sitting in state number 237 and where he is sitting in state number 3997, then that way of looking at world will be called an atomic state. So in the atomic state representation, states are indivisible, there is no internal structure in the states. Okay? Whereas we could define state variables like the seat where Vishwajit is sitting, the seat where Harsh is sitting, and now the value for seat where Vishwajit is sitting could be seat 1 in one state and seat 35 in the other state. There we can look at two states and say, okay, state, we are going inside the states. State is not just a number, it is made of state variables can take values, and now we can compare two states and say, oh, only Vishwajit moved. The fact that you can compare two states and figure out what changed is not possible in the atomic state world, but it is possible in the propositional state world. Then people developed this further and said, oh, why propositional? We can go first order. So the world comprises of objects and relations. So the objects would be chairs and the objects would be people, and the relation would be people X, person X is sitting on chair Y, and sitting would be the relationship, and we will describe the world in terms of objects and relations. And so a particular manifestation of which relations are true in the world will create a state, right. So this is the atomic agent view, the propositional agent view, the relational agent view, and if you have functions over objects, then that is a first order view. So there is full theory here of how do I represent the state. Let us quickly look at an example. Suppose I have 2 rooms, there can be dirt in 2 rooms and I can have a single vacuum cleaner robot, and this vacuum cleaner robot is in one of the 2 rooms, then I have 8 states, whether there is dirt in the first, dirt in the second, and where the vacuum cleaner is. If I call them state 1, 2, 3, 4, 5, 6, 7, 8, that will be the atomic view, right. If I say that my state has 3 propositions Boolean, dirt in the left room true false, dirt in the right room true false, Roomba in the room true false, vacuum cleaner bot, and 3 values like true true false, false false true, they make a state that will be called the propositional view. And relational view would be that I have Roombas, I have rooms, and I have a relation in robot room, dirty room, and then that would create my world, then that will be called the relational view. So, based on this, we can define a state space and a more interesting representation for the search problem, for the problem. So, now I have not defined the right way to represent a new problem, I have only defined that there is some notion of a state. So, from in the next class, I will first give you a general representation for an atomic agent's input. What input would it take, which is set of states, operators, start state and goal test, and what output is expected from the agent, which is a path from the start to the goal. We will first crystallize this idea, and having crystallized this, we will then get into the various algorithms to achieve this, and for the next week and a half, we will only work on algorithms to achieve this. So, this is a good point to stop, and we will meet tomorrow. Thanks.